Hello guys, in this video I am going to explain the solution of this question number 3 from chapter 11 of this book Engineering Circuit Analysis by Hayt, Kemmerly and Dermit. In this question it is asked that we need to calculate the power absorbed at t equals to 0 minus 0 plus and t equals to 200 millisecond by each of the element in this circuit, means these elements, if it is given that Vs is equals to minus 10 u minus t. Now when it is said that the Vs is equals to minus 10 u minus t, it means that we know that Vs, this ut, it is this, right? So u minus t, when we have this u minus t, it means this. It means u minus t, it will be 1 for t less than 0 and 0 for t greater than 0. So it is opposite to ut. We know that for ut the signal is ut is 1 for t greater than 0 and 0 for t less than 0, right? So over here this u minus t, it is just opposite to u minus t. So when it is said that Vs is equals to u minus t, it means that at t less than 0 the signal is 1, and it means that when we say 10 ut, it means that the Vs is equals to 10 for t less than 0 and 0 for t greater than 0. It means that this circuit can be redrawn and it is 10, and this is the condition for t less than 0, and it is the condition for t greater than 0, right? So over here Vs is equals to 0 volt. Now since it is 0 volt, it simply means that we can replace this source with a short circuit. So our circuit, it will look like this when t is greater than 0, and when t is less than 0, then only the voltage is there. Now the question says that we need to determine the power for t 0 minus 0 plus and this, and we also know that when voltage source is there, so at this time this inductor is going to accumulate the energy, and once it accumulates the energy, then this inductor, it can be replaced with a short circuit. So since 10 volt is there, from minus infinity to 0 seconds, right? 0 minus seconds. So it means that our circuit, this inductor, it must be behaving as a short circuit. So overall our circuit, it will be like this: 1 ohm, this is I, and this is 10 volt for t less than 0, because since the circuit is in this condition from the last infinite time, so this inductor is replaced with a short circuit. So over here the current that is flowing, this I, it will be 10 upon 1, so it will be 10 amperes, right? So at t equals to 0 minus, means just before the switch is changed, means just before the condition is changed from t less than 0 to t greater than 0, the current that is flowing is 10 ampere, right? So we can write that at t equals to 0, I is equals to 10 ampere, right? Now it means that when this battery is removed and when this battery is replaced with a short circuit, so at this condition, the initially the current that is flowing, it is 10 ampere, right? Now after that, in this circuit, this the condition of the circuit at t greater than 0. Now if I determine, we know that this current IT, it is expressed for this RL circuit, this IT let me put this as IL t, right? So this IL t, it is expressed as a e power minus r by l t, right? Or simply rl by rt by l. Right, now a is a constant, and this constant we can get the value by substituting this condition that at t equals to 0, because we know that at from this, since at t equals to 0 minus current is 10 ampere, so current will in this circuit, because inductor has the property that it will try not to change the current, so at t equals to 0 plus also current will remain 10 ampere, right? So it means that at t equals to 0 current will be 10 ampere. So substituting this value in these equations, we will get 10 equals to a e power minus r into 0 upon l. So it will be 10 equals to a, right? So our answer for this, it will be 10. Just a minute. It will be 10. Let me check if I did everything correct. Just a minute. Okay, so over here I did one mistake, that over here it is minus 10, it is minus 10, so it means minus 10 means that this will be minus 10 volt, so it means we need to put minus 10 over here, and minus 10 means that this expression over here it will be minus 10, so our current it will be minus 10 ampere, right? So at t equals to 0 minus current will be minus 10 ampere, at t equals to 0 plus current will be minus 10 ampere. Now substituting this value, I will get this minus over here, so the value of a, it is this, right? And now if from this I will get our ILT, we will get minus 10 e power minus, what is r is our 1 upon 1 into t upon L is 250, so we can write 0.25, right? So rearranging this, we will get minus 10 and this into 100, so cancel, so it will be minus 40. So this is the expression for the current, right? Now once we get this, we can determine our VLT. What is the formula? Formula is L di by dt. Means we have this, so we will differentiate this current. So differentiating this current, we will get like 4. L is our 250 millihenry, means 0.25. So 0.25 into dil by dt. So this expression, differentiating this, we will get minus 10 into e power minus 40 into minus 4. Right? So this 0.25, like if we put this, so we get this and this 4, and this 4 will be cancelled with this, so minus 1, right? So we will get this minus 10 into minus 1, it will be 10, so 10 e power minus 40. So this is our VLT, right? It is volt, it is amperes, right? Now once we get the, now we will determine the power absorbed by the inductor, and the formula is VLT into ILT, right? Now substituting the value, VLT is 10 e power minus 40, ILT is minus 10 e power minus, so it will be minus 100 e power minus 8t PLT. This is our instantaneous. This will give us the instantaneous power. Now, since the question is that we need to calculate the power absorbed by the inductor and the capacitor, inductor and the this register and the inductor at t equals to 0 minus 0 minus 0 plus and at t equals to 200 milliseconds. So now we will evaluate it. Now we get this. So over here PL first 200 milliseconds. So it means that I will substitute the value e power minus 8 and 200 milliseconds is 0.2. So substituting this value, I will get the answer as minus 2.02 watt. So this is our first answer. Second answer, we need to determine the PL at 0 minus. Now at 0 minus we know that the current is over here. Now the current is 10 ampere, right? And over here, as you can see this diagram. So at 0 minus, this VL, it is 0 volt since it is short circuit. So at 0 minus, at t equals to 0 minus seconds, our VL, it is 0 volt, and since it is 0 volt, so it means that our PL, which is VI, so it will also be 0. So at put 0 minus over here. At 0 minus, power is 0. So this is our second answer, right? Now coming to the third, at 0 plus. If we look at 0 plus, so it means that we need to substitute. Substitute 0 in this equation. So substituting 0, we get e power minus 8 into 0, so it will be minus 100 volt. So this will be our third answer, means we get the power absorbed by the inductor at 0 plus 200 milliseconds and at 0 minus. Now coming to the resistor. Now at t equals to 0 minus, VR, it will be, now since the resistance is 1 ohm and the current is minus 10, so VR, it will be minus, means I into R, so it will be minus 10 volt, right? And since it is 10 volts, so power at VR at 0 minus, it will be V into I. So VR is minus 100 and I is our this VR is 10, right, into this minus 10, so we get 400 watt. So at 0 minus, power absorbed by the resistor, it is 400 watt. Now coming to at t equals to 0 plus. At t equals to 0 plus, VR, it is equals to VR, it will be again equals to ILT into 0, or let me put a general formula first, that VRT, it will be the current flowing through the resistor into R, right? So the ILT, our ILT, we get, it is this minus 10 e power minus 40. So minus 10 e power minus 40 into R, which is 1. So our VR, it is VR, it is minus 10 e power minus 40. This is VRT. Now PRT, it will be VRT into IRT. So IR, or we can say IL, because both are same. So VRT, it is minus 10 e power minus 40 into ILT, it is minus 10 e power minus 40. So we get 100 e power minus 8t. This is VRT. Now once we get this, now we can substitute the value at t equals to 0 plus. PR 0 plus it will be 100 e power minus 8 into 0. So we get 100 watt, right? At t equals to 200 milliseconds, means 0.2 seconds, our PR, it will be 100 e power minus 8 into 0.2. So this will give you 0.202 watt, right? So these are the three answers. So at 200 milliseconds, this is at 0 plus, and this at t equals to 0. So this is the answers to the first part of the question, where the voltage is this minus 10 u minus t. Now the second part of the question says that if the Vs, if the value of this Vs, if it is equals to this. So let me redraw this circuit again. So if I redraw this circuit, our circuit, like the given circuit, it is right, it is 0.25 h, it is 1 ohm, this is ILT or IT, you can take anything, and Vs, it is given as 20 plus 5 ut, right? Now 20 plus 5 ut, we know that ut is equals to 1 for t greater than 0 and 0 for t less than 0, right? So it means 5 ut, it will be this, right? And 20 plus 5 ut, in that case it will be, means 20 will be added to this, so it will be 25 for t greater than 0 and 20 for t less than 0. So from this we can conclude that at t less than 0 the voltage that is supplied, it is 20, and after t greater than 0, at t greater than 0 the voltage applied is 25. So we will have two circuits. One circuit will be this 0.25 h, 1 ohm, this is I LT, and this is 20 volt at t less than 0, and the another circuit, it will be this 25 volt, 1 ohm, and 0.25 h, and this is ILT, and this is for t greater than. So now from this two circuit we can determine the power. So before determining the power, we need to determine the ILT for both of these circuits. So in this circuit, like at t equals to, like since the circuit is in this condition from the last so many time, like from a minus infinite time, so it means we can redraw this circuit, and we can replace this inductor with a short circuit, because inductor behave as a short circuit after some time. So since the circuit is in this condition from longer time, so the inductor will be replaced with the short circuit, and it means that over here VL, it will be 0. This is 1 ohm, this is our current, right? And this is 20. So this, with this we can say that current, it will be 20 upon 1, so it will be 20 amperes, right? So at I 0 minus, current is 20 ampere, right? Now similarly, we can try to determine the current at t greater than 0. So for this circuit, we know that the current can be determined with, like the solution of this can be determined by using the complementary function and the particular integral. So the, like the solution for this, it is the V naught upon R plus a e power minus RTL by L, right? Now V naught upon R. So our V naught, it is going to be like V naught, it is the maximum voltage. So 25 upon r is 1 plus a e power minus r is 1 t upon L is 0.25. So it means we can rewrite this as ILT equals to 25 plus a e power minus 4t. Right? Now over here we need to determine the value of this constant a. So the value of this constant a can be determined with this. Now since at 0 minus current is 20 ampere and we know that the current through the inductor do not change, like inductor try not to change the current. So it means at t equals to at 0 plus also the current must be equal to 0 minus 0 minus. So it means it is 20 ampere, right? So using this concept we can substitute current as 0 over here, 20 ampere over here at t equals to 0. So we will get this. So it means 20 equals to 25 plus a. So our a is equals to minus 5. Substituting this a in this equation, we will get ILT equals to 25 plus a is minus 5, so it will be minus 5 e power minus 4t. So this is our equation and the unit is ampere. Now once we get this, we will determine the VLT, which is L di by dt. L is 0.25 and then the differentiation. So if we differentiate this equation, so this will be the constant, so for this it will be 0. So minus 5 into e power minus 4t into minus 4. So from this we will get it is 1 by 4 into this and this, it will become 20 e power minus 4t. So we will get 5 e power minus 4t volt. So our VLT, it is equals to this. Right now once we get ILT and VLT, so we can determine the PLT by ILT into VLT, product of current and voltage. So we will get from this we will get like 5 e power minus 4t and 25 minus 5 e power minus 4t watt. Right now from this now we can determine VL at 0 plus. So substituting 0 over here, we will get the power absorbed at 0 plus. So 5 e power 0, 25 minus 5 e power 0. So we will get 5, 25 minus 5. So it is 5 into 20. So it is 100 watt at P 0 plus. And at 200, second we need to determine at 200 millisecond. So if you substitute 200 means 0.2 in this equation, so you will get 5 e power minus 0.8, 25 minus 5 e power minus 0.8. So the answer that you will get, it will be 51.19 watt, right? And the third we need to determine for 0 minus. Now for 0 minus we know that the current at 0 minus the current is 200 ampere, but our VL it is 0. So since VL is 0, at 0 minus VL is 0, so it means V into I. So voltage is 0 into current, so we get 0 watt. So at minus 0 we get VL, at 0 minus it is 0 watt. Now coming to the resistor. Now for the resistor, PR, P can be calculated as the current into R. R is 1, so simply it is square of the current, right? Now square, like since current flowing through the resistor and the inductor both are same, so it means that this 25 minus 5 e power minus 40 square, it will be our, so it will be 25 minus 5, 25 minus 5 e power minus 4t square, right? So this is our PRT. So substituting the value for 0 plus, substituting the value of t as 0, we will get 25 minus 5 e power 0 square. So it is 20 square. So it is 400 watt. For 200 milliseconds, substituting the value, we will get 25 minus 5 e power minus 0.8 square, right? So we will get the value something as 517 watt, right? And for 0 minus, the formula is like I square R. What is current? Current is at 0 minus, current is 220 ampere. So substituting this value, 20 square into R is 1, so it is 400 watt at 0 minus. So these are the answers for the second part of the question, where the voltage is this, right? So if you have any doubt, you can put it in a comment box. Do subscribe my channel and share this video with your friends and colleagues. Thank you.